This is the Illinois Nutrient Loss Reduction Podcast, Episode 31, WASCOB, the dry dam of the 21st century. I'm Illinois Extension's Todd Gleason. Well, Lauren Spaniel now joins us. She's with the Coles County Soil and Water Conservation District, where she serves as the resource conservationist. Lauren, thank you for being with us. I want to talk a little bit about WASCOBs with you today. First, I'd like to know what a water and sediment control basin might be.
A water and sediment control basin, or sometimes they're called catch basins, or as you said, WASCOBs, are an earthen embankment that's used to manage runoff and reduce erosion. They're usually used across a drainage way. So at first glance, they look a lot like a terrace, but terraces are usually longer and follow the slope of the land, while WASCOBs tend to be short and straight and are placed across the gully. So sometimes they're also called gully plugs, or an older term is dry dam, and all of those terms are kind of used interchangeably.
So how is it that one of these works to improve water quality?
WASCOBs work by temporarily collecting and storing runoff water. So it reduces the flow of runoff off a field, which also helps delay flood peaks. So once the water is collected, it is slowly released through an outlet pipe and also to some degree through soil infiltration. That can help reduce erosion. It can prevent gully formation or help heal gullies that have been there before, and it can also help remove sediment from the water.
And how does that improve the water quality?
When water enters the basin, it slows down and it's temporarily held there. That holding allows time for nutrients and sediment, like soil and crop residue, to settle and fall out. The sediment then stays in that basin so that cleaner water can slowly enter a standpipe. From there, it's taken underground to a safe, stable outlet downstream so that it doesn't cause more erosion. And periodically, like about once a year, maintenance is done to keep the WASCOB functioning properly. That usually includes removing some of that collected sediment and spreading it back out on the field. So, for example, cleaning out would be taking a scraper of some kind, pulling that extra sediment that's settled out and putting it back up on the field where it's useful. Iowa State University shows research that WASCOBs can reduce up to 80% of total solids and phosphorus by up to 85% that are leaving a field.
So what's the typical cost to install one of these, and more importantly, their cost share options that are available?
The actual cost is going to vary a lot depending on the specifics of your specific plan and the engineering design that goes with it. But as an example, a series of multiple WASCOBs might be needed to control erosion on a specific field. For a single WASCOB within that, that's say 1,800 feet long, $4,500 to $5,000 is about the average for our part of Illinois.
And the cost share options that might be available?
There are several different cost share and grant programs that can potentially help offset the costs to install a WASCOB. One of the most popular ones is the Environmental Quality Initiatives Program. Sometimes it's called EQIP, and that program is offered through the Natural Resource Conservation Service, NRCS. That program accepts applications year-round, but ranking and funding decisions are usually announced once or twice a year. It's a pretty competitive program, so your chances of getting funded tends to be better if you want to install multiple practices at the same time, but your local field office can give you more information and can help put together a plan so that you have the strongest chance of getting funded. The SWCDs also administer a program through the Illinois Department of Agriculture. That program is called the Partners for Conservation Program, or PFC. The funding level for that program varies from county to county, and the money tends to run out fast, but it can be a good option for projects as well. Some areas have additional funding opportunities, and your local field office can give you more information about your county's specific programs.
SWCD, of course, stands for Soil and Water Conservation District. What is the process like to install one of these earthen embankments, or WASCOBs?
There are 5 basic steps: planning, clearing the site, installing the plumbing, doing the earthwork, and then future maintenance. So the process starts with planning, and that includes a site visit from SWCD or NRCS staff, then an engineering survey. And once the conservation plan is made and that engineering design is finalized, there will be a pre-construction meeting, which is a representative from NRCS, the landowner, and the contractor, so that they can go over that plan together. Construction usually starts with clearing away surface vegetation and debris, so old riprap, for example, from the construction area. And then the plumbing is installed. That usually includes an outlet pipe and a riser or risers. Sometimes that's done a full season before construction of the earthwork. Having that extra time allows the dirt to settle around before the construction of the berm begins and makes the final product more stable. Once that outlet pipe and risers are installed, the slope and the elevation of the pipe is checked, the trench can be backfilled and compacted, and then the earthwork can begin. So material for the berm comes in from the channel at the toe of the berm and from the basin area upstream. Potentially adjacent areas could be identified in the design as well if they don't think that there will be enough from those areas. The material is moved in and it's compacted layer by layer to construct that berm so that can settle in and withstand future heavy rain events like we've been getting so many of lately. Even though the berm is compacted during construction, it will still settle over time. So they're usually built a little bit higher than the final finished desired height.
Are there any site considerations farmers need to know about?
Yes. WASCOBs usually work better than terraces on land with irregular and inconsistent slopes. The WASCOB spacing and placement is going to depend on your specific field. So it'll depend on your land slope, on your specific cropping and tillage patterns, your equipment width, and your kind of overall general management system. Also, just like a pond, they should be designed and located so that if the berm happens to fail, it won't result in damage to things like roads or public utilities or buildings. And there are also some limitations as well. The uncontrolled area draining to the basin is usually relatively small. At most, it'll be 50 acres, but it's usually way less than that. Also, sometimes the site is too steep for a WASCOB to be feasible. A stable outlet is also required. Sometimes if there's not an adequate stable outlet nearby, it would require really long runs of outlet pipe, so that also can make them not always economically feasible.
Any advice for farmers before I let you go?
Yes. Contact your local SWCD or NRCS field office if you are interested in putting one in. They'll talk to you about your field, your concerns, and they'll help you figure out what practices could address that problem. They are also a good stop if you need financial assistance to help with the project. They can help you apply for cost share programs right there in the office.
Hey, thanks, Lauren. Lauren Spaniel is with the Coles County Soil and Water Conservation District, where she serves as the resource conservationist. Now we're joined by John Pike. He's an agronomist, a consultant, and a farmer with Pike Ag LLC near Marion, Illinois. Hey, John, thanks for being with us. Can you tell me a little bit about yourself and what you do?
I am a private agronomist involved in research and consulting here in Southern Illinois. I live in Marion. I'm involved in projects all across the state. I was a former research agronomist for University of Illinois and was in charge of agronomy research at the Dixon Springs Ag Center before that center was closed. And I do similar work in fertility and water quality research and other types of agronomic work across the state and throughout the Midwest now.
So as a farmer and an agronomist, do you like how the WASCOB performs?
Yes, I think it's a good, sound conservation practice that has a fit in a number of areas. I think it's a lot like other practices that we have. It is at its best when it's used in combination with other conservation projects and processes. But I think that in a number of places where we have those pretty extensively across the bigger part of Southern Illinois, they tend to work very, very well when they're managed and maintained correctly.
What are your suggestions for farmers considering these?
Well, I think the first off is to consider what your problems might be as far as soil erosion and soil conservation on your farm or on a particular field, and evaluate what the best solution to that might be. In a lot of cases, WASCOBs, or as they're commonly referred to in many areas, terraces or dry dams. Uh, they have a good fit. The whole idea behind that is the erosion process is a combination of the erodibility of the soil, the steepness of the slope, and the length of the run. And what the WASCOB system does is it breaks up the run of the slope to slow down the velocity of water, and then the WASCOB, or the earthen structure that's involved in that, uh, backs up water and allows the sediment to settle out of that, and clean or cleaner water is discharged then at the end of the pipe. So while it's a good sound conservation process that works very well, it doesn't completely eliminate erosion. It's just a matter that it slows it down. Now, if it's paired with other practices such as no-till or cover crops, the benefit of that can be magnified quite a bit. But I think in the big picture is that what we see in Southern Illinois, and in any part of the state or the country where you would have sloping fields, where waterways are common, and the waterway would be a remedy for preventative gully erosion in a lot of cases. It allows us to farm fields across the slope on the contour that might have to be more practically farmed up and down the slope with the modern day equipment if a waterway was used. But the WASCOB system can be designed to fit equipment and the field area available to farm on a contour and be able to work very well.
Hey, John, thank you for your insight.
Sure.
That's John Pike. He's a farmer, an agronomist, a consultant at Pike LLC, located near Marion, Illinois. Not very far from him is Carbondale and Southern Illinois University, where Dr. John Schoonover is, and he serves as a professor. Dr. Schoonover, thanks for being here today. I take it things have changed just a little bit in your college since the last time we talked.
I was a professor in the College of Ag Sciences. Now I'm in the College of Agricultural Life and Physical Sciences. Been here 14 years. I teach a couple of classes in watershed management and 2 classes in soils.
What research are you doing related to WASCOBs, and can you share your preliminary findings there?
Yeah, so this project started out with the Illinois Farm Bureau. Actually contacted me and put me in contact with a landowner up in Menard County who just recently installed a series of WASCOBs, or was in the preliminary stages of doing the installation. And we got together, and I decided to write a proposal with Illinois NREC, which got funded. So we've got this project going on up in Menard County now, where we're looking at 2 WASCOB watersheds. Each have a series of 2 WASCOBs within that watershed. One of those 2 watersheds has cover crops planted, and another one has no cover crop planted. And then we also, for a control, compared that back to just 2 ephemeral drains that go through the field. One of those we planted a cover crop and one without. So we kind of have this 4 treatments going on. We've got 2 cover crop treatments and 2 WASCOB versus no WASCOB treatment. Some of the preliminary findings we found so far. Overall, for dissolved reactive phosphorus, this is like the overall WASCOB. So just comparing the 4 treatments, the DRP is about half in the WASCOB watersheds compared to the no WASCOB. As one might expect, these have been researched for a while with sediment and TSS, total suspended solids, and those numbers are quite a bit lower in those WASCOB watersheds as well. And then nitrate is also lower. So that's looking at the overall systems within a system, within like the WASCOB drain itself. So we have, each one of these are equipped with control structure where we can monitor the discharge and we can also monitor the stage within each one of those basins. The ones without WASCOBs have partial flumes at the end, so we can also do a comparison of that water coming out of the outlet, so how much drainage we're getting through these basins. The basins are retaining water about 12 hours on average, I'd say. So they're holding water back for a little while, and that's allowing for some processing going on. So we're seeing DRP concentrations, or dissolved reactive phosphorus concentrations, about half of what we're seeing in the non-WASCOB watersheds. So there is some microbial processing going on. TSS is settling out. We have some denitrification probably occurring in those watersheds as well, because we're seeing lower nitrate concentrations in those outlets compared to the upper basins.
Explain what these look like to me.
So you'll have a berm that cuts across a small valley, so you need some topography. You'll have a little berm, and then you have a riser pipe that comes up at the bottom of that basin. So it's a kind of a combination of a dry dam and a basin. That's the water and sediment control basin. So there's an outlet pipe, so water will rise up in that basin. Like I said, it's staying about 12 hours in our system, and that's going to be dependent on the size of the tile, the riser outlet. So you can, if you have an 8-inch tile versus a 6-inch tile, you're going to get quicker drainage. And some folks are even putting in 12-inch tiles, which gets that water out of there even faster. So it's a lot of it has to do with residence time, and I think a good time would be about 12 to 18 hours, so you can have some of that microbial processing going on, and you have more settling of sediment and things like that. So it's the tile size is driving a lot of it, and then you got the amount of soil you have to move. So there's kind of this economic balance between tile diameter and the amount of soil. So do I put more soil in to raise the water higher and put a smaller pipe in to let it drain slower, or do I move less soil and put a bigger pipe in so it doesn't overbank the berm? So there's kind of an economic balance of tile size and the amount of soil you got to move. So yeah, it's just another alternative for, if you got an ephemeral drain coming off a field, you've got two choices. You can either you got three. You could do nothing and fill it in every year, because, you're going to get erosion, and then it's going to knock you out of your tractor seat every time you go through or through the combine. So you're going to have to fill it in with a dirt pan. So that's kind of like the Band-Aid approach. Fill it in, let it blow back out. Fill it in, let it blow back out. So the other option is either a grassed waterway or one of these dry dams with a WASCOB to kind of stair-step that water down that ephemeral gully to prevent erosion. And it keeps your soil on site, so it prevents it from getting washed down to the neighbors or down into a pond or a lake or wherever it may go. So it's kind of this stair-step down. And, between those two options, you got a grassed waterway, so you're taking out, 25 feet on each side of that ephemeral gully if it's a 50-foot buffer, and then you're taking that out the length of that gully. Or you can put this WASCOB in, take out less land, of production, because you don't have the grass strip out there occupying your farmland, and you can farm through it or farm around it. And it just costs maybe a little more to install, because you got the tile cost and then the moving of the dirt. But in the long run, you're not losing all that topsoil.
Right, and so and because you're tiling the rest of the way out from the WASCOB out,
yeah,
right?
So that's how you're slowing the water down with the dam, and then allowing it to slowly go down that pipe, and it doesn't erode when it's inside of a pipe.
Depending on the topography, you can get rid of a waterway, even.
Yeah, the grassed waterway. Yeah, you can eliminate that. So that, is going to save you. It all comes down to economics with a farmer, because it's going to cost to install the tile. It's going to cost to move the dirt. It's going to cost a lot less to plant a grass strip. But if you do the calculations, 50 feet wide times how many other 100 feet long, that could be an acre or two of production that you're losing. So you could be losing those crop yields, in over 10 years, that's going to add up to maybe the cost of a WASCOB.
Thanks, John. John Schoonover is with the College of Agriculture, Life, and Physical Sciences. He joined us from the Southern Illinois University campus in Carbondale for this episode 31 of the Illinois Nutrient Loss Reduction Podcast. The program was produced in conjunction with Illinois Extension Watershed Outreach Associate Jennifer Woodyard-Jones. As described in the State of Illinois Nutrient Loss Reduction Strategy, Woodyard-Jones works in phosphorus priority watersheds. I'm Illinois Extension's Todd Gleason.